Hey guys, so today we are jumping ahead to the notes called Proving Trigonometric Identities Part 2. This unit is coming to a close. So those of you who were a little confused or didn't like this unit particularly, we're almost done. We'll be moving on to something new shortly. So the first thing that I want to chat about is that today I'm going to be posting a problem set instead of the homework that I want you to complete by Thursday night. And it's going to be using Monday and Tuesday's notes. So what I did was I posted all of the identities that you need to know for this unit right here. Okay, so these are from the formula sheet. These are the ones that we've learned. You do not have to have these memorized. Obviously, you can use these as a reference. And then I also posted the unit circle down here so that we can use that as well. So these are actually going to be using a lot of all the stuff that we've already done. So let's look at number 2. Okay, so just like any other trig proof, what we need to do, I'm just going to make this circle smaller so we can see. Just like any other trig proof, what we want to do is look for the side that we can simplify. So in this case, the side that we can simplify is this one. That's the one we're going to do because that is a sum of tangent, or a tangent of a sum. So we want to take this side, just like before, and make it look like that side. Okay, so let's first think about tan of two things added together. Well, that's going to be tan of A plus B, and that is this formula right here. So what we want to do is take this formula, take the left side, and rewrite it like that. So tan A plus tan B over 1 minus tan A times tan B. So let's see what we get there. So tan x plus tan pi over 4, so that's A and B right here, A and B, over 1 minus tan x tan pi over 4. Now, what you probably recognize here is that tan of pi over 4 is just going to be a number on the unit circle. So pi over 4 is right there. Tan is y over x. So the tan of pi over 4 is square root of 2 over 2 over square root of 2 over 2, which reduces to 1. So that alone is going to make this a lot simpler to work with. So the next step, I'm going to write tan x plus 1, because tan of pi over 4 we just found out was 1. And then 1 minus tan x times 1, which again, we don't have to write times 1 because that's just tan over x. And I hope you recognize at this point, we have already proven the identity. So that first one was pretty straightforward. It's basically just plugging into the formula and recognizing that tan of pi over 4 is just the number 1. All right, let's move on to number 3 now. Okay, so this one's going to be a little bit more complicated because we're going to be using 2 formulas. So first thing we want to do is figure out what side we want to simplify. I think this one's pretty obvious. This is the more complicated side over here. So if we take that one, we have 2 formulas. We have cos of 2 times an angle and sine of 2 times an angle. So let's look for the formulas for cos of 2 times an angle. Remember, there's 3 of them. Now, which one to use? Honestly, you can use any of them, and they will give you something similar. And the problem will end up simplifying to tan of the angle either way. But there is an easiest way to do it, which is this middle one. And the reason the middle one is better is because we have sine already on the bottom. So that's a good sign that we, pardon my pun, that's a good sign that this is probably going to simplify a little bit easier. So let's replace cos of 2 times the angle with 1 minus 2 sine squared angle. So 1 minus, and then I'm going to replace this with 1 minus 2 sine squared, and then that's an alpha. If you want to just write x, that's fine. It kind of looks like an x anyway. On the bottom, we have sine 2 of an angle, which only has one formula. 2 sine angle, cos angle. Okay? Now, what you probably recognize is this is going to be 1 plus negative 1 plus, we change the signs of both of those, and 1 plus negative 1 cancels. So all that's left on the top here is 2 sine squared alpha, and what's left on the bottom is 2 sine alpha cos alpha. Think about what's going to cancel here. Well, the 2's cancel. One of the signs cancels. We have sine squared on the top and sine on the bottom. So all that's left on the top is sine alpha, right? So all that's left is sine alpha over cos alpha. Well, which one is sine over cos? Well, that's tangent. Tangent is sine over cos. So equals tangent alpha, which is what we wanted. So there's number 3. So in some ways, these are a little bit simpler than the ones we did before, just because a lot of times you're just using a formula and plugging it. Okay, so let's look at number 4 now. So again, the side that we want to use is probably this one, because this is going to be one of the half angle formulas. We have tangent of a over 2. So let's look for tangent of something over 2. Again, there's 3 different formulas that we can choose from here. Any of those 3. So let's think about which one we want to use. Now, generally, this first one we don't use very much because that is the most complicated one. We have a square root in that one. We have plus or minus. It's just a lot more complicated. There's a couple of situations that we may talk about when you use that, but we're going to use one of these. Does it matter which one you use? Not really. This one's going to be a little bit easier to simplify, so let's use the middle one. So tan of alpha over 2 is the same as 1 minus cos alpha over sine A. So 1 minus cos A over sine A. Now, we want to make it look like this one. So what we can do is split it 1 over sine A minus cos A over sine A. Well, what is 1 over sine A minus cos A over sine A? Well, 1 over sine A, we know the reciprocal of sine is cosecant. So this is cosecant A minus, and then what is cos A over sine A? Well, that's cotangent A, which is what we wanted here. So there's number 4. Now, those are actually we're not going to do number 6. So those are the 3 that we're going to do here. Okay. After this, I am going to be posting just a short couple problem, maybe 3 problems in a problem set that I want you to try and turn in. So these are pretty short notes here. Please reach out on Microsoft Teams, write in the general chat if you have questions, because that way my answers can help all of the students in the class at the same time. I want you to ask. I am willing to help you on any of these assignments. You're not on your own here. So please reach out, let me know. Be specific with your questions. Don't just say, I don't get this, because there's no way I can help you if you say that. You need to be specific. All right, so that's it.